Okay, this is the Chapter 4 test. I want to go over problems 23 and also problems 24, and then you can ask questions tomorrow. 23. Suppose particles moving along a curve defined by the parametric equations. A portion of the graph is shown to the right. Find these three derivatives. Okay, so we need the derivative of x with respect to t, derivative of x with respect to t. We know that x is negative 6t, so this is negative 6. The derivative of y with respect to t. Derivative of y with respect to t. I would probably rewrite the equation here so that it becomes 1/3 t to the negative 2, just so we can use our power rule. Then dy dt becomes negative 2/3 t to the negative 3, which you could write as negative 2 over 3t cubed. Okay, the derivative dy dx is going to be the slope of the tangent line, and we know that's the derivative of y with respect to t divided by the derivative of x with respect to t. And assuming we got the first two, this is just a matter of putting these in here, minus 6, and this is minus 2 over 3t cubed. Now, obviously, if either one of these two were wrong, then the slope is going to be wrong, but maybe we can recover that by looking at the graph. If we clean this up a little bit, the negatives cancel. What do we get? We get negative 2 over 3t cubed multiplied by 1 over 6, right? So the negatives cancel, and then 2 goes into that. So how about 1 over 9t cubed? So that's a nice cleaned up version for that. Okay, part B, find and plot the location of the point t is equal to 1/3. Okay, so if we go back and look at the graph, and we know x and y are given by these equations. So x of 1/3 is going to be negative 6 times 1/3, which is negative 2. And y of 1/3 is going to be 1 over 3 times 1/3 squared, which is equal to 3. So negative 2, 3. This is the location where t is equal to 1/3, right there. Note, by the way, if we were to draw a tangent line at this location, the slope of this tangent line would be this derivative evaluated at that point. And if we just did a, off the cuff, what is m tan? Here's the slope of our tangent line. M tan at t is equal to 1/3 would be 1 over 9 times 1/3 cubed, which works out to be 3. Okay, and this does have a slope of 3 to 1. In fact, you can sort of imagine that point, and sure enough, 3 to 1. Okay. What else were we supposed to do? We're supposed to use the derivatives to describe the motion. Well, dx dt, we said, was negative 6. That means the change in x over the change in time is negative 6, right? So we're moving that way. We're moving to the left. And dy dt, by the way, this is constant. That doesn't change. But dy dt did depend on t, remember. Dy dt was this expression here. So negative 2 over 3t cubed. Negative 2 over 3t cubed. And if we evaluate that at t is equal to 1/3, you should come up with negative 18. So that means change in y, change in time. Because we're negative, we're moving down. You use both of these together to describe the motion of the point. Okay, so we're moving down and left. If we go back to the graph, that implies that we are moving along the curve like this. Okay, so this is our location, and we're moving this way. We're moving down and left. Okay, so down would be an appropriate thing to describe there. Now, as a bonus, I wanted you to try to give me the vector direction So now you have to think trig a little bit. The vector direction, we use vectors with these little components. Okay, change in x was -6, change in y was -18. So that would be a good direction. If you want to divide through by 6, you could. It would be -1, -3. Okay, so we're going to the left 1 and down 3. And again, that sort of makes sense by looking at the picture. So you're going to go left 1 unit and down 3 units. That is the vector direction that we're going right there. Okay. Let's see. I also want to talk about 24. There were a couple things you had to do here. First, you had to verify that the point was on the curve. That's only worth 1 point out of this whole problem, but it's easy to do. You have to just put x is 0, and y is 1. And just make sure that when you do that, x is 0 and y is 1, that this comes out to be a true statement. The left side is 1, the right side is 1, 1 is equal to 1. Yes, the point's on the curve. Okay, the second thing you had to do was differentiate implicitly to come up with an expression for dy dx. So in the end, we have to have dy dx is equal to dy dx is equal to some expression. And then we just had to verify that if we plugged our point in, if we actually plug in the point 0, 1, we were supposed to get 1/2. So that was sort of a check to make sure we had the right derivative. And it does say be careful when you differentiate this term, and I've got xy squared in parentheses with a negative out front. So we just have to be careful when we do that. Okay, going from here, let's do the calculus. The derivative of x is 1. Now, this is a product, so we have to use the product rule. The derivative of the product is the derivative of the first, 2x times the second, plus the first, which is x squared, times the derivative of the second, which is dy dx. Okay. Now we have this product, and it did say be careful of that. Okay, so let me see. Let me put a minus sign. Again, we have a product. I'm going to use parentheses here to keep it straight. The derivative of a product is the derivative of the first times the second, plus the first times the derivative of the second. The derivative of y squared is 2y dy dx. And again, note the parentheses. This minus sign is going to have to be distributed here, which makes that second term there negative. On the right side of the equal sign, the derivative of x is 1. The derivative of minus 2y is minus 2 dy dx. And the derivative of 3 is just 0, right, because 3 is a constant. Okay, so that's the calculus step. Assuming we did all of that right, then you'll have, and you do some basic algebra, you'll have the correct derivative, and then you just need to verify that when you plug the 0.01 in, you get the right value. Okay, so cleaning this up a little bit, the ones go out very nicely. Let me go ahead and distribute and just sort of clean things up a little bit here. We have 2xy plus x squared dy dx, and then minus y squared and minus 2xy dy dx. I would just rewrite this instead of x2y as 2xy. And on the right side, we have minus 2 dy dx. And that's it. Okay. So let's move all the terms that have dy dx to the left. So we have x squared dy dx, 2xy dy dx, and then plus 2 dy dx, and then all the terms that don't have dy dx, I'm going to move to the right. That one I'm going to go over, and that one I'm going to go over. So y squared minus 2xy, and then we divide. Okay, so dy dx, y squared minus 2xy, and of course we'd have to factor out this. But you'll have that, and that goes on the bottom here. So x squared minus 2xy plus 2. Okay, so there's our derivative. And then if we, just as a check, if we evaluate this at 0, 1, we get in the numerator, we get 1. And in the denominator, x is 0, so we just get 2. And that's what we needed. Okay. Last thing we had to do was, let's see, consider the curve when x is 1. I'm going to be putting 1 there, there, and there, and there. There are 2 possible y values, y1 and y2. So we're supposed to find these. So let's go ahead and put x as 1 plus y minus y squared plus 1, 1 minus 2y plus 3. Clean this up a little bit. What do we got? We got 2 plus y minus y squared is 4 minus 2y. I like to get everything on one side. And I really like the coefficient of my square term to be positive. Let me move these guys over here. So I have 0 on the left, and on the right I have positive y squared minus 3y, and then 4 minus 2 is 2. Okay, so that's what happens when x is 1. And then it says rather simple algebra to find the 2 y values. Well, sure enough, this problem is rigged. This factors very nicely as y minus 1, y minus 2. So the 2 values are 1 and 2. Okay, so we could find that. That was worth a couple of points just doing the algebra. And then the last thing you had to do was evaluate dy dx at these 2 y values. So dy dx evaluated at the point 1, 1, and dy dx evaluated at the point 1, 2. Now, assuming you got the derivative right, back in this page here, if you actually got the derivative correct, this piece right here, right, and then you plug in 1, 1, you'll get a value. And if you plug in 1, 2, you'll get a different value, and you were supposed to do both of those. Okay, so let's see if we can maybe, well, let me just, it's on the other screen, but if you just go back and look at that, you'll see the derivative we came up with was y squared minus 2xy divided by x squared minus 2xy plus 2. Okay, so let's go ahead and plug in 1, 1 first. X and y are both 1, so we get 1 minus 2 over x is 1, y is 1, and we get, what's that, 1, take away 2 is negative 2, 1, take away 2 is negative 1, plus 1 is 1, so negative 1 over 1. That's the slope at that location. And then at the second location, we're plugging 1 and 2. So we get 2 minus, plugging in 2 minus 4. And we're plugging in 1 minus 4 plus 2. All right. So what's that? Negative 2 over negative 1, 2. So those are the values we got. Something's not quite right here. Let me look at my solution sheet. That's where I made my boo-boo. Let's see. This is supposed to be 0. Let me redo this calculation here. Okay, y is equal to 2. Okay, so that's 4 minus 2 times 1 times 2 is 4. There we go. Okay, so that's 0 on top. And as long as the bottom isn't 0, we're okay. So we have, see, x is 1. So we get 1 minus 2 times 1 times 2 plus 2, and that's not 0. So what do we have? We have 1 minus 2 is negative 1 plus 2 is 1. Okay, so that equals 0. And those are the two problems that I really want you to go back and look at again tonight sometime. We'll talk about them tomorrow in class. Okay, let me go ahead and stop this, and I'll make that available on